Hello and welcome everybody to Advent of Code 2023, day 15. So, thankfully, after what have been 3 very difficult days on the trot, day 15 is a mercifully straightforward one. So that has made me feel very happy this morning. And yeah, it's kind of a simple enough problem. It's not too difficult. There's basically one sort of data structure you need to solve the problem, and he pretty much tells you in the question you should use that data structure to solve the problem, and it makes it easy. So with that said, let's have a look at the problem and a look at some code and yeah, go through this. So day 15, lens library. So we have focused that parabolic reflector dish from the last one with all those rocks. And so we follow where the beam's going, and it's all going into the side of this big building on another mountain on the island, which is the lava producing facility. So you come into the facility and you get greeted by a reindeer, for once not an elf. And the reindeer basically brings you to this book called the Initialization Manual. Basically, your whole job here is you need to initialize this facility without burning it down or melting it out or whatever. And yeah, so basically the way that we're going to do this is that he then goes on here to describe a hashing algorithm that's going to be used to solve this problem. So he says you have this initialization sequence here, and for the first thing you need to do, you need to take this initialization sequence and you need to compute the hash with this algorithm that he's described above of each of these values that are separated by the comma. So he says the hash is sequential, so it starts at 0, and then as you read in each character, you get the ASCII version, you get the ASCII code number for that. You add that to the current value, you multiply it by 17, and then you get the modulus of 256 of it. So there's the remainder of if you were to divide by 256, which is modulus of it, and that becomes your next value. So when you read your next character, you add it to that, and you just continue that sequence, and that is how you compute your hash. So with his algorithm, the hash of hash is 52. So he wants you to go through all of your input sequence, which is just this big comma separated string, and compute the hash for each of these individual ones. And that's it for the first part. So just compute this hash, and it is relatively straightforward. So let's have a look at the code to do that. So this is my code. You see, this is one of the shortest problems. It's as short as some of the very early day problems are. First thing we're going to do is we're going to read in our whole sequence, which is basically, so in our case, what I've done here is I've read in the line, split it by the comma, and then taken each sequence and split it into an array of characters. And then for each sequence, I take so in this case, my step is an array of those individual characters, and I just run this accumulating total, which computes the hash basically. So you take the original value, you add on so in Ruby, this ORD operation, I think is ORD short for ordinal, maybe? I'm not sure. ORD returns the ASCII value of a string character. So you add those together, you multiply it by 17, and you get modulus 256, and that returns some value. So that returns this returns your value. In our case, we're gonna stick that into an array of values, and at the very end of it, we just sum those all together, and that gives us our answer. So it's pretty straightforward. It should be very fast. It's not really doing a huge amount of work, and yeah, it's pretty quick. Not a huge amount more to say on that really. It's just a hashing algorithm. So this is actually, though, this type of question is interesting because it's kind of hard to see where he wants to go with this in terms of like it's something that you can do, and this is a test for that thing that it's doing. But you can, like this kind of problem he's asked before, where it's basically like, design a thing that does X, and then in part B, we're going to take that thing that does X and we're going to use it to do something. So the entire purpose of the part 1 input is just to validate, yes, you are correctly able to compute this hash using this algorithm. So now with that hashing algorithm, go do something else. So that's essentially what he set us up here to do. You've computed this hash, now go off and do something with that hash. So let's have a look at part 2 and see what he wants us to do with that hash. He goes on to describe that the sequence is actually a whole bunch of lenses, and there's like commands associated with those lenses. So if we go back to our sequence here, he's saying that these characters are an identifier basically for a lens. And he says that the next character after that is an operation. So we've got an equal sign or we've got a minus sign. So if you have an equal sign, it means that, okay, let's not jump too far ahead. So we have our lenses, and he essentially says that we have 256 boxes, which is suspiciously similar to the value of 256 up here. The trick to that is that when you do a mod of a number, you'll always get a value that is between 0 and that number. It has to be, since the remainder of the division can't go over that. So what will happen here is, for any number, any sequence that you would compute the hash for, you'll end up with an answer that corresponds to one of these, what they're calling boxes in this case. So he says that you compute, so when you detect this lens, it is going to go into one of these boxes. So you basically use our hashing algorithm, but don't apply it to the entire string. Now just apply it to the lens portion of the string. And that should tell you into which box that lens needs to go, basically. But so now we'll go back to the operations thing. So that just tells you which lens corresponds to which box, but it doesn't tell you what to do with it. So the minus symbol tells you that if you go to that box, and with all the lenses that are there, if you detect that lens is there, you remove it. And then the other part is the equals one, is if that lens doesn't exist, you insert it into the end of that and assign that value that's there, which we're told is the focal length of the lens. And then you're told if the lens does already exist there, you just update the value as it stands. And that's it. So the second part, he doesn't really tell you. So he does, I'm trying to see where it says it in here. Oh, yeah. So it goes on to explain how performing each step in the initialization sequence produces calls the Holiday ASCII String Helper Manual Arrangement Procedure, or hash map for short. So it's basically telling you this is a hashing problem. Use a hash map to solve this problem. So anyway, this just goes on just to describe all of the stuff there. And so then here's just an example of going through a sequence and what you'll end up with. So we get this OR_n equals 1. So OR_n, when you hash it, is going to give you box 0. So then we'll just set that equal to 1 in here. And then we've got this one, CM minus. So that's basically not going to do anything because the CM doesn't exist anywhere yet. So we can just kind of ignore it. It's not going to do anything. Then we've got QP equals 3. So that's going to map to box 1. We put QP in there. You get the picture, going on and on. The only one thing that you can do that sort of optimizes it is that so we're told there's one hash anyway, which is definitely the boxes, from 1 to 256 there, that's definitely a hash. But the trick as well is that makes this quicker is that the values that you get are also a hash. So these, what he just has here listed out in a list, this is also actually a hash, which means it'll be quicker to operate on. He doesn't explicitly say it, he just sort of states, some rules here to do with ordering and stuff. Now, so it might not strictly be the case that this would work for every programming language data structures, but in Ruby, hashes do follow a certain ordering that, well, so there's sort of an implicit ordering with a hash. You can't guarantee the order in a hash ever, but there is sort of an implicit order that, like, if you insert the value, if you insert a new key, they will be in the order that they were inserted in, basically. So that is sort of a pseudo thing that he does in here, he states in here. But yeah, so it's basically, you can take it that the inner part is a hash as well. And so that means it's easy enough. And that means that these operations are quite easy to do. The minus and the equals operations are very easy because it's just hash operations. So you look up, does it exist in the hash, and remove it. And then also you look up, does it exist in the hash, set the value, or update the value. It's quite straightforward to do with a hash. Harder to do if you model it as an array. But yeah, it is actually just a hash. There's nothing else special about it that makes it not a hash, really. Except that the ordering, so you can have to kind of make an assumption that the ordering is going to hold, but that's, in Ruby anyway, at least that's fine. I don't know, maybe in other languages it isn't, but yeah, so that's it really. So we'll have a look then at the code for that second part. So yeah, I assemble my hash with 256 items, 0 to 255. Then I start going through the sequences. I need to, so the first thing you need to do is you need to just determine which operation is in your sequence, whether it's a minus or an equals. So if it's minus, I create this, I just joined it down to a string so I can use this split operation in a second on it. So I go, split to give me the lens. So if it's a minus and you split it, you'll just get a value for the lens. Then I pass it into this hash out thing, this is the hash algorithm that we designed earlier on. So I compute the hash of it, that gives me the key. Then I take my map, look up the key, and then I'll call .delete on that. So I've initialized this map to have a hash inside it, and that's it. So you delete it. This will be a no-op if the key doesn't exist, and if the key does exist, it'll just remove it from the hash, and that's all you need to do. So then the other side of that, if it's an equals, we'll pull out the lens, the value of that lens itself. We'll compute the hash for it, and then all we do is just set the value. So we take the key, we take the lens, and then we'll set the value, and that will be what's it called? That will just update as well other values. So if there was to be a duplicate, it'll just update it. If it doesn't exist, it'll set the value. That's it. Simple, straightforward. So then the last thing you have to do is just, it says you need to compute the total like focusing power of this setup. So for that, he gives you the formula down here. So it's, for every single lens that's in here, you'll take the box ID and add 1 to it, because we know it has to start with a 0. Then we'll multiply that by the lens slot. So this is the part where I mentioned about the ordering. So officially, as you add and remove lenses, they have an order. So for the hash in Ruby, at least, the order is just implicitly whatever's there when you go to enumerate it. And in Ruby, that'll be the order of when you enumerate it will just be the order that they were first added to it. So basically the order that they would be in the underlying data structure that's there. And so as long as you can rely on that, then these slots will be accurate. If you remove one, it'll just pop out, and then the rest of them will buff up the way. And then if you add a new one, it'll always add into the bottom. And if you update one, it'll just stay in place and update itself, which is the ordering rules that he described. So as long as your implementation of a hash matches those ordering rules, I think you should be okay. But I'm not certain if you'd be guaranteed in every language or every implementation of a hash that would actually be the case. Not certain. Or maybe it is. Maybe that is actually a defined thing about a hash. I actually couldn't be sure. But anyway, we get that slot number. So you see they go like 1, 2, 1, 2, 3. So it'll be different for each box. And then we get the focal length, which is the numerical value of that lens itself. Multiply them all together and then add them all up, and that gives us our answer. So yeah, in the code, we do that here. We access each box and each lens. I have this order thing defined, which I say starts at 1, and then as we loop through each of the lenses that are in that box, we'll increment that by 1, and then that's our formula. So box plus 1 times the order times the lens, and then we take all those powers and we'll sum them together at the end, and that gives us our answer. And this is also very fast. It's not computationally super intensive. For the sample runs in less than a millisecond, and then for the input it is a few milliseconds, and that's the answer, and that works. So that's about it for today. It was a nice straightforward one. A couple of little things that, like, if you're comfortable using hashes, if your programming language is native support for hashes, then you're going to be fine with this. Dictionary in Python, the exact same thing. And yeah, the only little caveat is to do with that ordering thing, and also spotting that inner list basically of lenses could also be modeled as a hash. Makes this a hell of a lot faster. If you were to do this with just an array and like searching the array, it would be slower. I don't think it would be like massively slower that it would make this a really, really difficult problem to solve. But if you do use a hash for the inner part, it's very quick. So yeah, that's it for day 15. Thanks for watching, guys, and I will see you all tomorrow for day 16. Oh, but by the way, I'm still working on my day 12. So now that I've got this over with early, I'm going to go back to looking at day 12 again and see if I can solve it. But anyway, I'll see you guys tomorrow for day 16. Bye.